This is going to be an end of the year edition, so lots of cool stuff that you can expect today. If this is your first time, hi, I'm Vish, and my slides just froze. Yeah, hi, I'm Vish, and I will be your host today. And the Hasura Community Call is a monthly event hosted by us every last Thursday of the month at 9 a.m. Pacific time. This time we decided to do it in the middle of the month just to make room for the holiday spirit and just make sure that everyone is able to join. This is also the place where our engineering and product teams hang out with the community to showcase some cool features that they're working on, exciting product updates, a deeper look into the roadmap, RFCs, and everything awesome. So also, not too long ago, we changed the format slightly to accommodate not just cool features that are work in progress, but also newly launched features. So without further ado, let's take a brief look into the agenda. We start off with some really cool engineering demos and kickstart the agenda with a Hasura product update by our CEO and co-founder Tanmay Gopal. Followed by today, we are going to be showcasing some cool new features and also features that are work in progress. So the first one will be REST connectors by Thiru, followed by streaming subscriptions by Karthikeyan. Antoine will be showcasing the work that the team is doing with remote schema to DB joins. And Praveen will be showcasing public graphical and Vercel integration work. And last but not the least, Philip, who will be showcasing SQL Server Mutations work. Also, every month, we invite someone from our community to showcase all the cool projects and work that they are working on, whether it's something that they're building using Hasura or for the Hasura community. And this time, we have someone special, Muhammad Al-Qasim. Muhammad built a Hasura permissions viewer with Vue, Vuetify, JS, YAML, and Vue.json pretty. So I actually recently came across this project by Muhammad in the Hasura Discord, and they shared it. They shared about it as part of a contest, Hasura Tips and Tricks contest, and we absolutely loved it. So while working on a major refactor for their internal permissions, Muhammad realized that they realize the need for a user-friendly way to review permissions in Hasura. So they'll also be doing a short demo of how they built this in just an afternoon to make sure that there is a way to review permissions inside Hasura for your projects in a user-friendly way. Please go ahead, Tanmay.
I was just going to set a little bit of context for what we're going to for a few things that we launched and a few things that are coming in. So let me just quickly share my screen and I will show you the three main things, right? So the first, which is REST, making it easier to bring REST APIs in, right? So what was happening was when you folks were using actions, or if you folks are using actions with existing APIs, it was fairly troublesome that you had to kind of map the, there was a middleware kind of thing that was required to transform the Hasura payload into the payload that your REST endpoint might have. And so what we've done, and this is kind of what the rule will show us, is a declarative transform so that you can transform the GraphQL kind of mapping into what the action expects. And of course, a few action enhancements as well to make that easier, especially supporting custom types, which I think is already available on a PR. So that kind of then makes it much more easy to bring in an existing REST API, right? Now there's two main kind of use cases that we're seeing for this, right? The first is being able to integrate existing APIs. So we're going to start working closely with folks and putting material out around if you have an existing application with, say, Flask or Node.js or Django, and you want to make that bridge a little bit easier to bring that into Hasura, right? But you want the reads from Hasura, say, and you want the writes to be going to your existing Django application, for example. Then that connector becomes a little bit easier. And the second is also for starting to leverage kind of maybe some SaaS services directly into your GraphQL API, right? And so the use cases around this will evolve for sure, but as we as to as you start kind of using multiple services and some parts of multiple services, you can then bring that in much faster rather than having to write a middleware, right? And of course, with actions, you can always join kind of the response of an action back to a database. So that is always available, and that will also get enhanced. There's stuff around action to action joins, right? Like joining between actions, and action to remote schema joins, and remote schema to action joins, which are a few more permutations and combinations that lie ahead of us. But those will happen as they happen too. I think the other piece that we've kind of built upon this was is putting together a kind of a hub of different kinds of a community repository of different types of these connectors, which are essentially these transformation snippets, right? That Drew will show us later in the call. And this will kind of allow us to, all of us to kind of work together, the community and partners, right, coming together to maintain these little snippets, so that if you want to bring in Notion or Firebase or Auth0 or something into your API, right, or Algolia or Elasticsearch's API, for like running a search but then dereferencing an object that's inside Postgres, that will become easy to bring in because somebody would have already written out that little connector, and then bam, you can bring it into your application, and then you're good to go. The last piece is Google Cloud support for Hasura Cloud. So we've added support for GCP. You should see a form on your cloud accounts where you can request for GCP, and we'll feature flag it for you. And this is very exciting. This is interesting, especially yesterday we had on Hasura Cloud, we had a little bit of an outage, about a half an hour with AWS's, with a few regions going down on AWS. Now, even though we're multi-AZ, in a particular AWS region, because we're multi-AZ and both AZs or all AZs of regions, US East and US West, went down, some of those instances were not able to connect to users' databases. There's a network connectivity problem. With support for Google Cloud, it's nice because we can start kind of exploring and doing some work into providing a multi-cloud failover, right? This may or may not work for different scenarios, but that's the kind of stuff that we can start exploring as well. And we'll start putting some work into here to make sure that there's some multi-cloud resiliency also. This year has been interesting in terms of some different kinds of outages and how that's been impacting us and of course other folks too. What's also really nice about GCP is with our support for BigQuery that was already there, and with GCP Postgres, it'll be nice to kind of bring that directly on Google Cloud. All traffic will go over the Google Cloud backbone, so no extra egress charges, and then of course we'll have peering, VPC peering, and private linking as well, so that you can just have private connectivity to your data systems. But those are the big updates. There's a lot of stuff that has happened over the last few weeks since we last chatted on the community call. We had a few events. And so you'll see stuff on the release notes, and you'll see stuff on the cloud changelog. There's a whole bunch of tiny stuff a lot of tiny enhancements that we've landed. But with that, back to the folks for their demos. All right.
Thank you so much, Tanmay. So I think next we have Karthikeyan. Karthikeyan is going to talk about streaming subscriptions. So let me just set a bit of context here. Hasura GraphQL Engine currently supports live queries for real-time capabilities. Now, we realize that our users are increasingly using Hasura subscriptions for chat and also other heavy data real-time applications, for which we will be introducing a new streaming API, which lets you receive incremental results over a cursor. So Karthikeyan will be showcasing the work that we're doing for streaming subscriptions.
Karthikeyan, go look at Karthikeyan's face. He's so excited to show streaming subscriptions to everybody, and everybody's like, streaming subscription.
So, my name is Karthikeyan. I work in the server side of Hasura, and today I'll be presenting the streaming subscription feature. I've been working over the last month, more or less. Okay, so before that, what is a GraphQL subscription? So GraphQL subscription is essentially a query where the client receives an update whenever the value of any field changes upstream. Okay. So what kind of subscription does Hasura support currently? So currently we support the live query subscription where when any value in the result changes, we return the entire response to the client back, and not necessarily all the individual events leading up to the result. So streaming subscription is essentially what I've underlined here. I mean, it does that. So a streaming subscription will return. So what is the streaming subscription? A streaming subscription will return the latest result of the query being made based on the latest value of the cursor provided by the user. So when you make a streaming subscription, you provide a initial value. You'll choose a cursor. A cursor here is a column, and you'll give it the initial value, and the subscription will start streaming from there. So I'll just show how does it look like. So likewise subscription. So let's say we have started, and this the first order being inserted. So it'll look like this. So T1 is the timestamp, and T2 is when the second order is being inserted. So the server returns the order 1 and order 2, and similarly for T3. So how will this look like if you are streaming instead of doing a live query? So in this, as you see, you'll only get the order that is being inserted here. So T1, T2, T3. So you'll only see those orders. Okay. So before this, I'll show a small demo. So this is the streaming subscription, and this is the our normal live query subscription. So as you can see that I've provided a cursor, and here the column I've chosen as the cursor is the created at column, and I've set a value. So this value is the value from where the streaming will start. So it will get, so if I start this from now, it will give me all the messages that are being created after 2020 0101. So on the left hand side I have the streaming subscription, and on the right hand side I have the live query subscription. Okay, so let me stream. Okay, so these are all the messages I'm getting. I have which are after 2020 001. Oh, I have the Excel. Okay. Okay, so I have all the messages. So let's see what happens when I add a new message. Let's say from 1, 2, 3. Okay, now you see this is the next message that was being, since we are streaming, so this is, as we are inserted the row, we are only getting this message. In live query subscription, you would have got all the messages which are being subscribed. Okay, so this is the streaming subscription. So what are the benefits of using this? So first of all, you can only get the data which you which has been changed if you can configure the cursor column correctly, and also the other Hasura features like authorization relationships and any Hasura feature which works with query will also work with streaming, except for remote schema related features, because we still haven't added support for remote schemas with subscriptions yet. So there are also some limitations for now. So currently only a single column cursor is supported, and for streaming to work well, the choice of the cursor is very important to get the optimum results. So an ideal cursor column should have unique and sortable values. And currently there's no back pressure support. That is, if the server is generating events at a rate which is higher than the rate at which the client can process them, then there's no way client can let the server know that it is not being able to handle. But we do plan to tackle this problem, but it is kind of challenging now. Okay, so there's this PR link. You can try it out. I've included the Docker image. So do let me know if there's any feedback. And there's also a surprise. So if you could scan the QR code, you'll see a surprise related to streaming subscriptions, where I have no way of getting acknowledgement, but yeah, I hope at least some of you are scanning.
Yeah,
I posted the link in chat too.
So depending upon your thought, upon how you perceive it, it is either a cake or a tower. So if you click on different lights, the light will toggle on and off. If you click on flows, the colors will change. So it is so this tower is a combination of live queries and streaming subscriptions. So if you see on your top right corner, the events that are being generated is a streaming subscription, and the lights which are being the tower is a whole live query state. So yeah, so that's all from my side. If any questions, I'll be happy to answer. And yeah, the demo was made by Jesse, so huge shout out to him.
I slacked you the link if you want to pull it up on your window so people can see those that aren't actually.
First to start off, that was a really cool demo, very insightful, and also like a huge shout out to you and Jesse working together on this and just making sure that there's a great example out there to understand how this works. Really cool. That was a really cool surprise that I didn't know of. So thank you so much, Karthikeyan, and thank you so much, Jesse, for building this. Yeah, if you have any questions about streaming subscriptions, I can see some questions already. Karthikeyan will be available in the chat, so make sure you have a chat with him.
I just add on to sorry, Vish. Just wanted to add on to two important kind of use cases for streaming subscriptions that we're kind of optimizing for. Right, one I think was a very pertinent question that came up on chat on the sortable column, and so there kind of one of the things that we're working on is putting together a demo to show how you can have a partitioned or sharded table as well. And so you can ingest hundreds of millions of events and stream them as well. One of the use cases that we're working on with one of our users is ingesting somewhere between 100 million to 1 billion events per day that are then being streamed to different services. And so that's kind of one kind of use case where there's this large volume of records that are kind of have to flow from one place to another. The other very interesting use case for with the same kind of streaming mechanism is for large lists of data, where if you have like you want to get like a API call for 1 billion records, and you don't want to paginate through it or set up cursor-based pagination manually. What you can do is kind of subscribe to this stream of a massive model, right? And wherever you left off, you can kind of directly, wherever the client kind of starts from is the cursor offset initially. And then kind of can keep kind of streaming it as that data comes in. So those are kind of the two use cases we're optimizing for. We're also planning to add in some kind of reference documentation on how to handle back pressure, which becomes really important with streaming. It's interestingly not too much of a concern or less of a concern with live queries, because with live queries you tend to know a little bit the shape of the result and the size of the result, right? So kind of back pressure is a little bit factored in. But with something like streams, your client can get like 1 billion events suddenly, and then your browser will crash. So, or your app will crash, or interesting things will happen with the MMP. So that's kind of a little bit of the context on streaming subscriptions, and we keep having more and more updates over the next few days, weeks, and community calls.
Awesome. Yeah, that definitely sounds super amazing. Thank you so much, Tanmay, for adding on to it. Next, we have Antoine with the remote schema to database joins demo, which allows us to extend our data join capabilities and also define remote relationships from a remote schema to a database table. So, Antoine, whenever you're ready.
Hello, everyone. Is my screen visible?
Yeah. Yes, it is.
Perfect. So hi, everyone. I'm Antoine. I work in the internal representation team. And we mentioned earlier that there's going to be two kinds of features. We're going to have ready that we want to show and the ones that are still work in progress. This one is definitely on the work in progress side of things. So we are working on extending remote joins to allow to join from a remote schema to a local database. I'm going to show you a quick demo of what it looks like at the moment. But before that, there are a few things I want to talk about. I want to talk about naming things, how we refer to the feature, how it creates some confusion, what solutions we have found for this. And I want to address what it's going to mean from a technical perspective, how the metadata representation is going to change, what the metadata API changes are going to be like. And of course, I will finish with a quick demo of it. So in terms of naming, the problem we faced, as you might know, naming is one of the most complicated things in computer science. The problem we face is that the word remote relationship has been used to describe a lot of things in the past. Originally, it only meant relationships from a local database to a remote schema. When we started working on DB to DB joins, we've extended it to mean anything from a local database to something that is remote from it, either a schema or another database. Now we're introducing a remote schema to database joins. So how do we refer to those? We had a few jokes internally. We called them remote relationships, or my favorite, long distance relationships. But what we have settled on is instead to redefine the vocabulary around them. Nowadays, we call remote relationship anything that is from a left-hand side to right-hand side that do not share any locality. And we call local relationships the ones that you know and love between, for example, two tables in Postgres. So nothing's going to change for the local ones. And this is purely a naming perspective. That also means that whenever we refer to a remote schema to database join or database to database join, we're going to be much more explicit in the naming, both in the metadata and the metadata API. Talking about them, you might be wondering, if we are going to be changing the way they're defined to be much more explicit, to reflect the fact that we want to be very explicit about what kind of relationship we're talking about, what does that mean for you who maintain Hasura instances? And the good news is nothing. We are going to support a full backwards compatibility of the previous format, the current one for you, the one we call internally the old format of remote relationships from source to remote schema, with the idea that if your metadata contains such a relationship defined with the old format, we will accept it perfectly fine. If you try to create a new one with the create remote relationship metadata command, we will accept this old format as well. And we will go even a step further when exporting the metadata or saving the metadata. If we detect that one such source to remote schema relationship was parsed from the old format, we will still write it with this old format, which means your metadata will remain compatible with previous versions of the engine. However, we will also introduce a new format, both for the metadata blob itself and for the new metadata API commands that we're going to introduce, that will allow to have a more unified representation of the different kinds of relationship, where regardless of what the left-hand side is, a source or a remote schema, we always define, as here in the example, the relationship as per the right-hand side, to a schema or to a source. From this, this unified representation will also allow us to work on some very interesting things in the future, but this is not a product announcement. This is purely a demo of what exists. So I will neither confirm or deny things that you might infer from this new representation. So let me quickly show you an example of how it works at the moment. An important caveat is I'm using a slightly old version of the code. So some of the things I have mentioned in the slides will look a tiny bit different, just because, again, I am using a slightly old version of the code. So let me show you. I have here a Hasura instance running with a remote schema, which is the GraphBrains API, which allows to query information about artists and songs. And I have a local Postgres source with a table that adds additional information about artists. So here I have two example pre-made queries. One is querying that remote schema to get the top 10 artists according to Last.fm, which gives me a bunch of artist names. And I have here my local artist info, which is my Postgres table that contains additional information about artists, like the number of gold records or their yearly disc sale. There isn't a lot of information in my database at the moment, but it's just an example. So one of the things I mentioned that this is not finished yet is we don't have yet a metadata API command to add such a relationship. So I'm gonna do it by just importing a metadata that contains the relationship. So here's the metadata as it stands at the moment. The remote schema is here. And here's the metadata I'm gonna import. It's exactly the same, except we're gonna be adding a relationship. Relationships in remote schemas are defined on the GraphQL type on which to operate. So we're going to be adding a relationship on the type last.fm artist, and that relationship will target the source default, the table artist info, and will do a mapping on the name field. So if I import this metadata, now I have my relationship defined. And if I go back to my last.fm top 10 query, I can now, when selecting information about the artist, I can do this additional info here and do a join, again, my local Postgres database. And if I run this, well, for most of the artists, we don't have a lot of information, but you can see that the join happened properly. So yeah, that's about it for me. That's, again, a work in progress. There are a few things we want to finalize before this is released. We will need to update the documentation to reflect those changes in naming conventions, that kind of things. But yeah, I'm excited for the things to come.
Thank you so much, Antoine. That was a really cool update. Definitely a lot of use cases that we can think of when it comes to like enriching our data from that is coming from remote schemas with the data that is coming from our database tables. So also, I love updates or like announcements that are also non-announcements. So looking forward to anything that the team works on. Thank you so much. Next up, we have Praveen. Praveen will be showcasing some really cool demos on public GraphiQL and the Vercel integration. Praveen, go ahead.
Hey folks, I'm Praveen. I work on the community team at Hasura. I have a couple of quick demos to showcase. First one would be around public GraphiQL, and we'll talk about the use cases on why this would be pretty seamless between sharing some queries from console, right? So typically, we've had use cases where we've tried some queries on the API console at Hasura. Like let's say, for example, I have this project with this endpoint, and maybe there are some tables which I've exposed on an unauthorized role, and I'm making some queries, right? So I've got a response, and I want to share this particular query and the endpoint around this to a collaborator of this project, right? Or let's say like a front-end developer who's building the app on top of this API. Now, it's become slightly cumbersome to share this console interface to a collaborator because you'll now have to restrict access to the console to not allow them to do destructive actions, right? So you will typically disable access to all of these tabs, and it's become slightly cumbersome to do just the console UI, the graphical UI, right? So, and you need to also be part of your project as a collaborator, right? So it's become a little bit more of a multi-step process to get into this, to try out the query for a front-end developer to get started. So what we've done is we've created a new public GraphiQL interface, which is accessible from the cloud dashboard, and it's also like an endpoint that you can directly go there. So, for example, if you're on your cloud dashboard, you will notice that there is a new API Explorer URL that you can click and then open. What this will do is it'll just pre-template your cloud endpoint of the project, the GraphQL endpoint. And potentially, if you have headers going forward, you can keep templating them as a URL parameter, right? So now that this is available, I'll be now able to make queries as usual, and the front-end developer can now start working on this query, right? So the use case here is that, and the ideal experience would be that you are already on the console and you have like a share link, which would generate the queries that you have here, along with the variables and the headers that you use. And you can actually technically just share that particular link, which would be part of this public graphical interface, right? So for example, this particular one, I have a query, which I can just paste it here. And this would auto-populate the query with the endpoint and everything, right? So it's part of the query parameters and stuff. So now you'll be able to make this query and get the response back. couple of use cases here. One is that you don't need to have collaborator access on your project. Now this is like a public endpoint, which can be accessed by anyone. And you can add your headers as you want. Two is that you can also test your local host endpoint as well. So for example, you're probably working on a remote schema, which is like a custom GraphQL server. And let's say you want to test that out as well, right? So you can use this interface because, for example, some servers would not give you like a graphical interface, especially with the header UI that you get with the console, right? Now you can actually go ahead and make the queries and test your remote schema example and get back the response, right? So this becomes like a bookmark for you. I've started using this to bookmark my queries, and it's the go-to place for me to quickly start testing out some queries, right? And it will work for both authorized queries. So you can add your headers if you have admin secret, and if you have some auth token that you want to test some permission layer for your tables, you will still be able to use this headers as well. So it's just basically a trimmed down version of API Explorer that you see on the console, but it's now publicly accessible on this endpoint. The endpoint is basically cloud.io/public/GraphiQL, right? So yeah, fundamentally just two use cases which I think will improve the experience for sharing with collaborators without the cumbersome process of adding them to the project and then trying out the queries, right? So now it'll become like a easy way to bookmark queries on a public working endpoint. Cool. So that was the first demo that I wanted to show. The second one was around Vercel integration that we've been working on. So this will allow us to create projects from the Vercel's marketplace. So Vercel has this integrations console where you can create a Vercel project and then attach it to like an integration, and you can create cloud project from their marketplace, right? So the use case here is that you will have a Next.js app deployed on Vercel, and you want that to be connected to your Hasura cloud project. And you make any changes to your cloud project, it will be synced. The ENVs will be synced to your Vercel account, right? So this will enable you to work on your Next.js app pretty seamlessly. You will have access to the ENVs, which will give you access to, let's say, the endpoint and the admin secret and other ENVs that are required for your Next.js app to work. So quick demo. So this will be like, this is still in an approval stage, right? So this is like this is how you'll add the integration to your Vercel account. So you'll select the scope of your Vercel project. You can select multiple projects where you want the Hasura integration to be integrated. So let's say, for example, you sign into your cloud account. And the two projects that you've selected in the previous step, they will be linked to the project that will be created now. So this is basically just a Hasura cloud project being created in the background for you. And once this is done, you will get the endpoint and basically the secret being populated on the projects, right? After you visit the console, you'll get the same interface, the same cloud project that you have, right? So and you can go back and then finish the setup on the Vercel dashboard, right? So this is pretty much automatic generation of the cloud project without coming to the dashboard. This is happening all on the Vercel side, right? And you finish the setup, you come back to Vercel dashboard, and here you can go back to your projects list on Vercel and then check out the env variables that have been populated by Hasura. So if you go to the environment variables, you can see that there is an admin secret that's been populated and the project endpoint that's populated, right? The primary use case here is that if you're using an Next.js API route for building your custom actions or remote schemas, for example, or events, in those cases, you will require an admin secret. And obviously the project endpoint, which is the GraphQL endpoint, is always going to be required for your front-end app to make queries and make some client-side integrations, right? So in all of these cases, you will require access to ENVs, which are values of your Hasura project. And these will be available now to you by default when you start deploying to production. So you will not worry about actually changing values on the ENV side, but you'll just actually worry about deploying these changes, doing a git push to your Vercel account, and then the Hasura's project is the ENV variables of Hasura project will be automatically synced to your Vercel account. So yeah, so this is the integration that we're working on in the final stages of getting the approval from the Vercel team, and this will be available on the marketplace for you to quickly try it out. And we believe this would help in the UX where any changes would be synced between these two platforms, and you'll not worry about changing values, right? So yeah, that's the demo that I wanted to show you. Happy to answer any questions.
Thank you so much, Praveen. That was a great demo. Also, I'm sorry if you folks cannot see my face, just having a bit of a trouble here, but I'm still on. So thanks for the demo, Praveen. I think those are really great features. Talking about the public graphical feature, I think it's going to be great for enhancing the experience for our users with learning and exploration. Or also, if you're running on production, just disabling the console for more important security updates currently involves a significant amount of overhead and management, and something like this is going to be really helpful. So that was great. And also we have a huge portion of the Hasura community, our user community, who loves working with Vercel. So the Vercel integration is definitely going to be a power pack duo with both, like being able to efficiently use Hasura and Vercel together. So thank you so much for that awesome update. And now we have Philip with the SQL Server Mutations work. And this is kind of self-explanatory, so I'll just let Philip take it away.
I'm Philip. I work in the data sciences team at Hasura, and we've been working on adding mutations support to MS SQL, which I will talk to you about today. So, what do we want to support? Basically, we want to support the same things as we do on Postgres, but for MS SQL, obviously. So we want to support querying, inserting through relationships, upserting, updating, and deleting, to sort of just enumerate all of that. And so the status of that is that currently we can do querying and inserting and updating and deleting. Updating just landed like yesterday, last night on CI. We're currently working on upserting. I can show you what the schema is going to look like, but it doesn't execute yet. And inserting through relationships, that's like on the plan, but not haven't quite gotten to it yet. And so most of these will follow the same schema, the same GraphQL schema as Postgres has, but upserting will be slightly different. And I'm going to show you. So, assume we have a single table that's just articles with an ID, some content, and a title defined on MS SQL. There's nothing there currently, but we can insert some. We can insert something that has a title and another title. They get IDs, and they are actually in there. Great. But we can also come up with a better title and update accordingly. So there, a better title. Oh, sorry, a better text for the title. That's the way it is. And of course, we can delete them. And they disappear as expected. And we also have this upsert feature, which looks slightly different than it does for Postgres. And I'm going to show you a bit more details about that. Well, we can run it, but it won't actually reflect, it won't actually work properly because there's nothing actually interpreting the schema yet. So it's just running a normal insert. All right, so why are these upserts slightly different? So this is the database schema. It's an article, ID, title, and content. And what we do for Postgres is that we have this onConflict keyword in the insert mutation, which mirrors, which is chosen to be like that because it mirrors the way that it's translated into Postgres SQL, because it has this, makes use of this onConflict subclause that Postgres supports on the insert into. But MS SQL doesn't have such a clause. So instead, what we're using is a separate statement called the merge statement. And we've changed the resulting schema to allude to this, so that it's maybe more clear to someone what actually goes on under the hood. So we call this if matched, and that lets you specify columns that you want to update and the columns you want to match on, which mirrors the same as we have for Postgres, where we specify constraints instead of an actual list of columns. And again, this is because you can see it has this when matched keyword in the merge statement, and that's what this if matched then alludes to. So yeah, it's it's a long road, but we're getting there. I'm happy to answer questions if you don't have on the chat. But yeah, that's what I have.
Awesome. Thank you so much, Phil. Yeah, the mutations work has been long awaited, and it really makes sense. If you have any questions around the mutations work, what's coming up as already described by Philip in his demo, or anything else around MS SQL Server support in Hasura, then we have a channel on our Discord, and make sure that you connect with the team there and ask any questions that you might have, and we'll be happy to answer them there. All right. So we announced some really big updates, exciting updates, as Tanmay mentioned during his product update, which further simplify data access for developers. And one of those exciting updates was REST connectors. So REST connectors allow for connecting REST endpoints with low-code simplicity through request transforms. And by transforming your GraphQL request using a minimal templating language, which we have our own templating language, you can often bypass the need for writing proxy functions for connecting existing REST endpoints with Hasura. And now these REST endpoints you might need for actions or your event triggers. So let's hear from Thiru around what's new with actions that we had already demoed in one of our action transforms that we had demoed already in one of our previous community calls, and also what's coming up with event transforms. Over to you, Thiru.
Hey everyone. Yeah, so we started off with this big feature that we launched recently. It's live in all the platforms, in OSS, also in cloud. So you can check it out today after these impressive demos that we'll be doing, and Jesse will be doing these demos with me. So yeah, so as Tanmay and Vish said, REST connectors are a functionality of Hasura where you can integrate any REST API. It can be a GET request, POST request, patch request, delete request, anything that is like a REST conformant API. You can bring that into Hasura via actions, right? And you could do this before, but what you would need to do is write some code, deploy it somewhere, have your action that you will define here, hit that endpoint, which will do the custom transformation. You will have to write that code, manage that code, and then it will pass that or forward that to your actual REST API, right? So this huge component in the middle, the middleware layer, is what we have removed with action transforms, and then you get like completely like no code or like declarative low code way to like integrate any of your APIs. So JC here has opened the actions page, and the first thing that we are going to do is see the types of the action that we want to define for this REST API, right? So very quick primer for those who are not familiar with actions. It's a It's part of Hasura where you come and define like an API that you want, and then you give an HTTP endpoint as the resolver for that API. So you can bring in custom stuff, do custom business logic, things like that. So here in the action definition, we can see what the API is. It's a query type, right? And it's Airtable. So it's actually going to connect to Airtable, get data from a different data source altogether. It takes a table as its input argument and gives an Airtable response. And what are these types? So Airtable response is defined below. It's going to send a set of records. It could have been, so it's a JSON B type. If you see here, it's defined as JSON B. It's a custom scalar, so it can use any value there, which is string parsable. But what we have recently merged in Hasura is support for nested action types. This is merged, so it should be out in the next minor release. And with that, you can even define like fine-grained types for records, right? We'll see what we get. We can define like individual fields for that, and the roadmap has like plans to make joins with these individual types, and that's just going to like be crazy for doing GraphQL federation, like different API joins, and yeah, it's going to be massive. So yeah, so let's move a little bit below. Then that was a type definition, and we have given an endpoint, the Airtable endpoint, as an environment variable, and so that's how it looks. And there's an authorization header also, and the key for that is also coming from an environment variable. So that's the thing. So that's your typical way of defining an action. But let's now configure a transformation. So if you look at this whole section, there are multiple components, but we'll focus on the first component, which is like, how do we change the request options, right? Like, how do we change the request method? In this case, we are going to set get as the request method. We have those other methods. By default, it's post, but we're going to transform that into get. The second thing that we want to do is change the URL, because the REST API, a lot of parameters are available in the URL itself. It's kind of it's a dynamic way of getting data. So here in this case, we are going to get a table as the input argument and construct a URL based on that input argument, right? So how do we do this? We have few context variables available, right? Like session variables available in $session variables name, right? And you can also set those things to try this out in this sample context area that Jesse just opened up. And there are other things like $body, which is just going to be your action body, which is your standard action body. This is documented in the docs. So you can use that to actually construct like custom stuff. So here we are going to use $body.input.table, because that's the format of your body, and we are going to actually use that to construct the URL. So that's how we'll define the transformation. So yeah, we can now save this and run this query. It's going to be Airtable and passing the table as the argument. There you go. So we have actually constructed a get query, passed a query string to that, which is coming from the input variable of your API. So this is a typical example of how you can integrate like different endpoints in actions, right? So that's the first demo. The second demo is going to be similar, but we are going to use event triggers to again show a different example. So here we have like we can create a new one or an existing one. Let me see what Jesse prefers. So yeah, so we have a table here called newsletter sign up, and we are going to set up a event trigger here, right? So we'll go to events. Okay, so that's the schema of this table. Right. So a name for our event trigger table, and it's on insert. So on every sign up, we want to send like a newsletter links to our users, and we have the Mailgun endpoint added here.
I'm like 90% there to be able to connect it to a real REST endpoint, because we were going to set it up with a practice one, right? I have a Mailgun REST endpoint here. It's ready to take an insert. But so we can kind of walk through maybe how we would actually do this in real life. So I have the base API endpoint, and now we're coming down to the actual get insert here. And so now you can kind of talk us through how we would use the insert payload from an event trigger to get the email address. Mm-hmm.
Okay. Yeah, we can do that, but I want to do something more fancy. Are you ready for that, Jesse?
I'm ready.
Okay, so let's change the URL to http://bin.org/post. Let's do a slightly complicated example.
http://org/post. Do I need to give it the protocol here?
Yeah, you can give
it. Is that HTTPS or?
No, it can be HTTP or HTTPS. Both are fine. So let's not add any transformation, right? Let's just save this.
Okay. I need to remove this.
Yeah, just remove that. Okay, and now let's insert an event.
I'll do this off page here. Create a mutation. Insert newsletter sign up. Give it an object. Email. Test at test.
You can just go to the data here and add it in this page itself. If I can't see your
probably could, huh?
Yeah. So just
not create table. Insert row. Hide these tips. There we go. All right. So test user at test.test.com, and double sign up is false. Save.
Okay. So we can go to events. And yeah, we can look at this event. Let's look at, it should be processed now, I believe. So let's just wait. Go to processed. Yeah, let's open this. So yeah, open the next one as well. So we can see the response here, right? So this was the request. And let's look at the response. So yeah, it's a very, so the response is basically the request returned back. So what we're going to do is, so the event trigger payload is very complicated. It has the old event, it has the old row, it has the new row, it has some metadata for your event itself, event trigger itself. So consuming that for an external API like Mailgun is like, yeah, it's going to be like a lot of work to integrate any external REST API, right? So what we can do here is make a transformation, and we'll see, like, we'll clean up this payload, make it very simple. Like we'll send just the email or one of the fields, and we'll change the body this time and not just the URL. So yeah, Jesse, if you can go back to the transform section in the event. Yep. Yeah. So now I won't touch the request options, so we can close that. It's fine. Let's change the payload. So there's a second section here. So the first one was for your URL stuff. The second thing is for your actual the body. And we have a sample input here, which is going to be your which is the regular body, right? We're going to transform that. So so that was the sample input. And if you look at this second thing here, we want to add something like, I think that let's just create a small object which has one key called email, and then we can get it from like $body dot the table name. We can look at the top. So there's like a lot of developer experience work done here on the console, where we auto generate sample inputs based on your table, so that it's easy for you to like see what the values you want to put in are. And there is autocomplete, there is some error suggestions and so on. So a lot of console work has gone in as well in the transforms feature. So yeah, please feel free to give us our feedback. And yeah, so the final thing, as you can see, is you have like the transform request body is going to be email and email, because that's what was there in the sample input. So yeah, let's hit save here.
Go ahead and insert a new
another
user. Mm-hmm.
Yep.
That's the German test@test.com for those who don't know.
Awesome. So we go back to events, look at the second event.
Which one would be this one here?
I think it should be sorted by time. So the first one. So yeah, so this time the payload is really, really small, right? As you can see, the payload is email. You can see the response is, so the response has like all the headers. That's what HTTP bin or post does, but there's a small key which shows like what the response is. So yeah, so the request got changed, and it's, yeah, we can see that we can see both the requests, because we did a request transformation. If we want to compare like what the original request was. So while Jesse is showing this, I want to make a small note about like the templating language that we're using to define the transformation. It's called CritiLang. It's inspired by Go. It's an open source library written in Haskell, open source. So like feel free to add any issues or add any more features to like add capabilities to transformations. So that's what's powering this. And finally, let's head to the Data Hub link, Jesse, so that people can see more examples and see like see more ways to integrate your APIs with Hasura, right? So yeah, so this is the Data Hub, and we have a lot of examples for these features, especially action transforms and event transforms. So do check it out and contribute if you like. Thanks, Vish. I think I ran over a little bit. Sorry for that. Thanks, Jesse.
No worries. Loving the live collaboration there, but that was such an awesome update, folks. That was a really cool demo. I think the REST API connectors feature is going to be really powerful. It's in terms of like just being able to easily write or like bring in your REST APIs, whether they're new or existing, without needing to write any custom code. And then having the Hasura Data Hub built on top of the functionality. Just having like a collection of pre-built integrations of popular REST APIs. So thank you so much for that demo. We're running a little bit over time, so I'm just, without further ado, I'm gonna call upon Mohammed with his demo on Hasura Permissions Viewer. Take it away.
Hey everyone, it's a pleasure to be here. Mohammed Al-Qasim here, tuning in from Riyadh, Saudi Arabia. I hope everyone can hear me and can see the screen. Yeah, I'll just start out with some context. Mizan is a project we've been working on for over a year. We started right away with Hasura as part of the tech stack. I'm one of the co-founders of the project. Mizan is an accounting SaaS built with multi-tenant design pattern. It grew to 60 plus tables before the launch, and soon after the launch, we were building one of the core features that was still missing. Which is allowing users to add collaborators to their teams when they're working in Mizan, like as a business in general. They could add sales members or purchasing members or stuff like that. And as we were going through that, there was a major refactor required, because initially when we built the Hasura permissions rules, we were going through a foreign key reference simply through the org ID foreign key on all of the tables. So as soon as we wanted to add more users, we had to add a bunch of additional tables and then build a view that concatenates all of that into something called an organization ACL. And then we built a relationship from the organization ACL to the organizations table, which was manually configured, such that we could simply replace all of the previous permissions with an additional level of nesting, which goes to check the organization ACL as a view. The refactor was actually done with pattern matching in the YAML file. So we basically did a search replace with regex. And that was quick and easy. It wasn't too painful. It took us a couple of hours, and that was kind of all right as soon as we knew what we wanted to do. However, as soon as we got to the point where we wanted to actually verify, like at least manually verify and get an overview for what the new permissions looked like, just to make sure that we didn't change anything that shouldn't be changed or something like that, we ran into a little bit of a problem because in Hasura, as great as it is, and we're huge fans, there's currently no clean way to actually look at the rules for all of the tables side by side. You would have to dig into to actually go into each table and check manually, which is a little bit too slow. So we thought there must be a simpler solution, and we took a couple of hours to basically build this. This was built in an afternoon. It's a fairly simple implementation. And what it does is basically it just grabs a YAML file, it parses it into JSON, you just drop it somewhere, you run npm run parse, npm run serve, and then you get this. I'll show a demo. I'll tab out of the slides and show a demo quickly. So this is what the live version of the viewer looks like. So you could basically navigate through the tables easily. If you click on any tables, you could have like a bunch of critical tables that you want to review side by side, grouped up here. You could add tables, and then when you're done reviewing, you could delete them back, go review another set. And as you navigate through this, you could easily just see side by side everything that you need to see, which was like a very significant time saver, quite honestly. The way this was done, I'll just show you very briefly how it was done. Of course, before I go there, I just want to show you where the repo lives. It's currently it lives right here. Like at GitHub, if you look up Hasura Permissions Viewer, it's a public repo. Anyone can clone it. There is simple instructions. You just need Node installed to try it out. All you need to do is simply drop a tables file, your tables file here, and then run the parse. And as soon as you parse it, you'll see the tables in JSON, and then it will basically be imported here. The whole app is just two components: the side navigation drawer, which you could use to navigate through the tables, and then the app.view. And we just use Viewtify and Vue.json Pretty to easily format everything into something that's user-friendly. And that's pretty much it, really. There's not much more to it. But it's quite interesting what you could do with the right tools. So we wanted to share this with everyone in case anyone needed something like this. However, like if anyone wanted to extend this a little bit further, there is a few ideas that we've entertained. However, we didn't actually go through with implementing them quite yet. I'm not sure if we will, quite frankly, but I'm just throwing the ideas out there in case anyone wants to, and if anyone is interested. There's a couple of simple extensions where you could simply dynamically create logical groups of tables, for example, by features, like billing features or admin-only tables, so you could review the sets of rules side by side. There's the concept of like persisting and sharing your view configs, either like locally, or you could even share an import string with anyone and they could just load it up and get the configuration for the review. And then there is also a few more advanced use cases, which might be overkill. However, just putting it out there, you could build some sort of filters. So you could easily jump to tables based on certain snippets of rules if they match up with what the tables actually contain. You could also like have the ability to rewrite permissions within the viewer itself. That would take some additional work if you want to have auto-completion, of course. A simpler way of, instead of full auto-completion, is to introduce reusable snippets into the workflow. For example, if you have a bunch of snippets that repeat very often, you could introduce that. And yeah, I'm sure there's more possibilities out there, but we just wanted to throw a few out in case anyone found it interesting. And that's pretty much it. Thank you very much for having me. And if anyone wants to reach out, I'll be here in the chat for a while, and you can reach me by email if you're interested. Thanks.
Thank you so much, Mohammed. That was a really cool demo and a really great overview of the kind of work that you folks are doing and why, like, what motivated this experiment and like this project that you built in just an afternoon, which was something that really that I found really fascinating about like how Hasura just empowers you to build things with ease and like super quickly, as long as you have an idea in mind. Also, folks, I know that we're running a bit over time. So without like taking much of everyone's time, I just want to give a huge shout out to the Hasura community call and everyone who has been involved in all of our community calls. The Hasura community call is 2 now. So we've successfully completed 2 years of these community calls. And if anything, today was a great reminder that in the midst of the pandemic, all of us are working from our homes and we're dealing with power cuts and technical issues or audio troubles while sharing our screens and presenting. But through all of these technical and like whatever difficulties, I think what really shines is the kind of work that we get to do with our teammates, with our colleagues, with our friends, and the communities that bring us together. So I'm really grateful to our Hasura community, and also wanted to give a huge shout out to all of our engineers who've been able to put together these quality demos for our user community, and not to forget you, our audience, our users, anyone who's listening in, for joining us every time, asking really valuable and important questions so that we know what our users are expecting, and we know what we should be bringing to the community next. And also I have a few quick community milestones that I wanted to mention. We are now a family of 10,000 plus on Discord and more than 500 people on our Hasura subreddit who get to share a lot of insights and discuss really cool things about the product that they love using. And for more than 400 million downloads of the Hasura GraphQL engine. So thank you so much for always showing your love and support and being here with the team. Also, a really quick shout out to the feedback form that we have. You folks make us help us make the community call better with your feedback. So if you have anything that you want to let us know about how we could make these community calls better and better every time we come back, please let us know through our feedback form at hasura.info/com10. We also have another form which you can see. We'll be sending it to you in a follow-up email later on. So if you really liked your Mohammed's demo, and if that is also something that you'd like to do in one of our upcoming community calls, please let us know through community call demo form, whether it's a project or a contribution that you want to showcase, or if you're using Hasura within your teams or your organizations and would like to share your experience with us, we're all ears. So just let us know. And yeah, this was the Hasura community call. We have it every last Thursday of every month, and we will be back with our next community call super soon. Hope everyone has a very happy and safe holidays, and thank you so much for joining us. Bye, everyone.